Hello my dear friends, I'm back again with my new video of mole concept. Okay, so we have learned about vapor density relation with molecular mass, about moles and volume of substances, like n equals number of substances by Avogadro's number is equal to molar mass, given mass upon molar mass is also equal to volume of substance divided by molar volume. Okay, today we are going to learn about molecular volume and empirical formula of a compound. Okay, so see, here is an example. See, molecular formula of glucose is C6H12O6. Okay, now I am writing it in the ratio form, C is to H is to O, 6 is to 12 is to 1. Now if we simplify it, we get, we will cancel it with 6, then it becomes 1 is to 2 is to 1. Okay, now empirical formula will be, now see, value of C will be 1, value of H will be 2 and value of O will be 1. Okay, so it becomes CH2. So this is basically empirical formula is the simplest form of the molecular formula. Okay, like suppose C2H4 is given. Okay, now if we write in the ratio form, then it becomes 2 is to 4, and if we simplify it, we get CH2. Okay, that's the simplest form. Now next thing comes is relationship between molecular formula and empirical formula. Okay, now molecular formula is equal to empirical formula into A. Okay, where A is the molecular formula mass divided by empirical formula mass. So we get the equation A equals molecular formula mass divided by empirical formula mass. Okay, now we have taken example of CHO2. Okay, now its molecular formula, empirical formula is given as 45 and molecular formula is given as 90. Okay, then we get the value of A as 2, then we get multiply it by 2, then we get C2H4O4, C2H2O4. Okay, let us see one more example here. Okay, vapor density of a compound is 42. If its empirical formula is CH2, then determine its molecular formula. Now we know that vapor density equal to molecular mass divided by 2. Okay, then it becomes, now we know the value of vapor density, so molar mass will be equal to 2 into vapor density. Okay, so it becomes 84. Now we know that molecular mass, molecular formula upon empirical formula gives us the value, then it becomes 84. See, molecular formula, molecular mass or molecular formula 84 by, we are given with empirical formula. So C has a mass of 12 and H2 means 2. So 12 plus 2 gives us 14. 84 by 14 gives us 6. Now CH2 into 6 will give us C6H12. Okay. Now there is one more topic, percentage composition of a compound. Okay, like we are taking example as C2H6. Now we have to find the percentage of C in C2H6. So mass of carbon upon mass of C2H6 into 100%. So this becomes mass of carbon. See, there are 2 carbon atoms, so it becomes 12 into 2, 24 upon there are 6 hydrogen atoms and 2 carbon atoms. So molecular mass will be 30. So 24 upon 30 into 100, which gives us 80%. Okay. Now next is mass of hydrogen. Now similarly we will put the formula mass of hydrogen upon mass of C2H6 into 100%. So it becomes 6 by 30 into 100, which is equal to 20%. So next thing comes is mass percentage of element in a compound. Okay, so it is basically calculated by atomicity of element multiplied by atomic mass of element divided by molecular mass of compound into 100%. Okay, let us see an example. This will help you to understand it. See this example. A compound contains 6.67% hydrogen by mass. If vapor density of substance is 30, then find atomicity of hydrogen in it. Okay, so what does the formula say? Mass of element in a compound, mass percentage of element in a compound is equal to atomicity multiplied by atomic mass divided by molecular mass into 100%. See, now mass percentage is 6.67% is equal to atomicity multiplied by atomic mass. Atomic mass of hydrogen is 1 divided by molecular mass. Vapor density is 30, so molecular mass will be vapor density into 2, which becomes 60 by 60 into 100%. So 1 0 gets cancelled, and on solving this we get a value 4 point something. Okay, so it is approximately equal to 4. Now see, there is one more question. 14.2 gram of a compound of phosphorus and oxygen contain 6.2 gram phosphorus. Determine its empirical formula. Okay, now here we will write in the ratio form. So P is to O. Okay, now mass is 6.2 gram of phosphorus it is given. Now total is 14.2. So 14.2 minus 6.2 gives us 8. So mass of phosphorus is 6.2 and oxygen is 8 given. Okay, now moles 6.2 by, what is the mass of phosphorus atom? 31. So 6.2 upon 31 is to 8 upon mass of oxygen is 16. Okay, so 6.2 by 31 is to 8 by 16. It gives us 2 is to 5. Now empirical formula will be 2 atoms of phosphorus and 5 atoms of oxygen. So it becomes P2O5. Okay, so that's all for today. Thank you.